welcome to, I guess we're still calling this Stan the Energy Man. But thanks for coming to my lunch hour. That's what we're going to be doing for my lunch hour every Friday, I think, for a while. And the subject is going to be all about energy. But before we get started with our guest today, what I'd like to do is, I know that Jay and Ray Starling have the negawatt moment on Wednesdays, so I try to think of something similar. And I'm just going to call it stray voltage. And so my stray voltage for today is I've been looking at, the grid and other things besides transportation, because I do mostly transportation as part of the High Tech Development Corporation and the Hawaii Center for Advanced Transportation Technologies. But we've had a kind of a slow, insidious migration of vehicles to the grid. And I think people are not really recognizing all that means. So let me just give you some things to think about in your spare time. We now have vehicles that plug into the grid, and there's already research going on about, how those vehicles can be used not just to take power off the grid for a recharge, but how to put power back on the grid when you need power back into the grid. And because there's so few out there now, we really don't think about the implications. But as we get more and more renewable energy online, we're going to need more and more storage on the grid. So there's a place for these vehicles and other vehicles that plug into the grid as storage. And the storage isn't just in one place. It's not one big gigawatt battery. It's a bunch of smaller but powerful batteries that are spread all through the grid. So here's the question. What does that do to a utility company's spinning reserve requirements? When you put all these batteries out in their grid where it can be used instantly, instead of having to spin a lot of reserve power back at your generator and push it out into your grid when you need it. So think about that and start thinking about things differently now, because vehicles aren't just for driving anymore. They're actually part of the energy storage on your grid. So there's your stray voltage from Stan, the Energy Man today. Today, we have with us Dr. Joe Pratt from Sandia National Labs, and he's here working on a project with Department of Energy and doing some great stuff with our own company, Young Brothers, our inter-island barge service company, Young Brothers, and I'll let him describe the project. But Joe and I have been working on this for about a year, and my role in it is HCAT and the Air Force are providing the hydrogen for this project. So Joe, welcome to the show, and I'm glad you could be here. You're only here for a couple days, so thanks for taking time out of your schedule. Yeah. And tell us a little bit about yourself.
Okay, sure. Well, Stan, like you said, I work at Sandia National Labs. I'm a mechanical engineer, and I work for over 10 years now in hydrogen and fuel cells. So, you want to hear about the project, I
Sure.
guess? Yeah, okay.
Yeah, well, tell us a little bit about what Sandia National Labs is, first of all.
Oh, good point. Yeah, so it's a good chance you may not have heard of Sandia, or it's not as famous as some of the other labs, but it's actually the largest Department of Energy laboratory, and we have a long history of expertise in hydrogen. I know everything about it and how to store it and how to use it, its properties. And so what's been happening over the last really 20 years or more is applying that knowledge to hydrogen systems for energy. And so Sandia has a hydrogen program specifically for energy, where we do everything from fundamental research on how to store hydrogen in different methods to using it in real life applications. And that's really the area where I work, is kind of the end of the research cycle, where you've gone from an idea to maybe a laboratory experiment to a prototype, and a company's now picked it up and they're producing something, and that's sort of where the last leap is. Okay, so how do you get this technology into the market and making money for people? That's really the bottom line for business.
Great. So these national labs, and there's several of them out there that the Department of Energy runs, are kind of geared towards that commercialization phase in a lot of ways. I mean, they do a lot of research, but there's companies that come to you and say, I really need to know more about this. Can Department of Energy help me figure out how it works? Yeah. So you kind of take it from there and work with these companies to get them to a commercialization stage. Is that a fair characterization?
Yeah, we do a little bit of everything. So we do work for Department of Energy or other federal agencies who want us to do some research, and then we work a lot with companies directly. Like you said, they have an idea, maybe there's a technical gap there they don't quite understand, we can help them out with to get them farther along. Yeah, it's very...
Okay, so is there a special process that you're familiar with at all, and how these companies like get into that realm? How do companies come to Sandia and say, hey, I've got this great idea or this great technology, and I'd like to expand or validate it and get it ready for bigger and better things? How do they do that?
Lots of different methods. So, you know, one thing you could do is call me.
Okay.
If you know me, or if you know somebody else at Sandia Labs or any of the other national labs, you say, hey, I have this idea, I want some help. And, you know, we can figure out the process to do that. If somebody didn't know who to contact, they can go to Department of Energy and ask for help. That's happened before, where we've gotten a call from the folks we work with in DC saying, hey, we have somebody who's looking for help in this area. We think you're somebody who can, so then that match is made that way. Somebody just goes right to DOE. And then each of the labs have a process, so I'm sure Sandia Lab and National Renewable Energy Lab, all the labs, you can go to their website, and there's, I'm sure, some place on there where there's going to be a place for small businesses or any business to get in touch and start collaborating.
Great, that's a good point too, because I've gone to the Department of Energy's website. There's an incredible amount of information on there. Resources, places to go, reports, publications that are already done that the average business person or person with an idea or an invention can go and look and see what the state of the art is on that particular technology. Mm-hmm. Learn about it, learn, you know, where it's at, what other companies may be working on it, and then look at the research that was done and see if it was validated before they dump a lot of their own energy and money into the project.
Yeah, I mean, one of the things we do is everything we do that's funded by the federal government is supposed to be public. So the intent is, when we do these projects, all the results are made public. You know, sometimes when we work with companies, of course, we want to protect their proprietary information. But from the national side, we really have an emphasis on trying to make as much public as we can for that reason.
Great. And this is one of those areas where, you know, I mean, everybody is critical of where federal funds are going. Mm. But this is one of those areas where what comes out of the labs oftentimes is the next big break or the next big technology that creates all the jobs and the big industry and the big technologies. And let's look at hydrogen, for example. You know, hydrogen has been studied for hundreds of years, maybe thousands if you go back to the Greeks. But recently, since probably the Civil War, there's been a lot of work done in hydrogen. But I would say over the last 15 or 20 years, it's kind of gotten focused and gotten a lot more attention, a lot more energy. And we've always known about the good characteristics of hydrogen and what it can do. But I think there's some images in people's minds, like the Hindenburg and the term H-bomb, that scare the daylights out of people whenever you talk hydrogen. Yeah. So why don't you tell us a little bit about hydrogen and the characteristics, so that maybe folks would be more comfortable with it? Because this isn't new, and it's not as crazy and scary as most people envision it, right, when they think of those other images I mentioned.
Yeah. So hydrogen is the lightest element, right? And one of the things about it that is good and bad is when it's in air, it's, I think, 14 times. I guess
right,
I'm
14
saying
times
this.
lighter than air.
Okay, good. I got it right because I'm on the record here, right? So 14 times lighter than air, which means if you have, you know, hydrogen and then you release it, it goes up at about 45 miles an hour straight up into the sky. It's so light, it eventually goes out into outer space. Okay, so that's good and bad. The good part is, because hydrogen is flammable, you don't want it to accumulate in a room or something where it might ignite. But it's really hard to contain it because it's so light of a gas. So that's the good thing, is safety perspective. You know, the thing that makes that difficult is because it's so light, it's very dispersed. And if you want to carry it around in your car, right, you have to get that hydrogen down into
squeeze it into a container.
squeeze it into a container. Yeah, so there's challenges with that. You know, the fuel cell cars that are coming out now all use high pressure to squeeze it in there. You're I'm sure familiar with all the work on metal hydrides, which you're using to, you know, have a smaller volume of hydrogen at lower pressures. So that's, you know, some of the real basic property is the fact it's so much lighter than air, right?
And hydrogen is also the most common element in the universe. So hydrogen's an atom. It's
Right.
a small, lightweight atom. And so when we're talking about hydrogen as a energy storage device, or some people say the word fuel. I try and stay away from the word fuel when I'm talking hydrogen. But it's the way you store energy. If you think of gasoline, or you think of methane, or you think of diesel fuel, and you look at the chemical name for those, you know, the CH, blah, 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 it all has hydrogen in it.
Yeah, right.
So I tell people, why are we fooling with all the carbon parts
Yeah.
and all the other parts when all we really need is that hydrogen part?
Yeah.
And why don't we focus on that and use it? So on the safety side, you mentioned it's flammable,
Yeah.
but when you store the hydrogen, it's actually got to be extremely pure.
Right.
We deal with what we call 5 nines. 99.999% pure hydrogen goes into those tanks in the vehicles.
Mm-hmm.
And 99.999% hydrogen can't burn.
That's right.
It's got to have air and oxygen in there to actually let it burn.
Right.
And so when it's stored in the tanks, and the tanks are special, they're double layered, they're aluminum alloy inside, they're carbon fiber wrapped outside, they have special valves on the end that release pressure when they're overpressurized, shut it off in accidents. In our vehicles, we have shut-off valves. So the safety piece has actually gotten a lot of research and
Oh, yeah.
a lot of validation by international safety groups to standardize across the transportation and other sectors how you store hydrogen and how you use it. So the safety piece has gotten actually quite a bit of technology built into it.
Oh, yeah.
And, you know, I probably shouldn't say this on camera, but I haven't heard of a major hydrogen accident since the Hindenburg. I mean, when you think about the headlines in the paper, you don't have to go back very far to find a tanker car that spilled a bunch of oil someplace,
Sure.
or a spill on the beach in San Diego
Yeah.
of oil that they had to clean up, or the BP Horizon in the Gulf.
Yeah.
I mean, you think about the problems you have with oil, and then you try and say, okay, well, when's the last big hydrogen thing we had? And quite frankly, because it does go up in the air so fast and disperse, because it wants to expand out to
Yep.
where it's at room pressure,
Yeah.
and then go up, it takes quite a bit to contain it
Yeah.
and put oxygen in the right mix and
Mhm.
make it do anything bad.
That's right.
So it's a lot safer than most people think. And that's one of the challenges we have when we work with hydrogen, is letting everybody else know it's not quite that scary. Some of the other things we've learned from the Hydrogen Safety Board and the California Fuel Cell Partnership, we've done training with our local fire department, because as you know, when Young Brothers started your project out here, we had to train the firefighters from the city and county and from the Harbors Division on what happens if you have a fire and there's a hydrogen element involved.
Right.
And the interesting things about hydrogen are, number one, no carbon in it, so that radiates very little heat. So that flame that we talk about pretty much goes straight up at 45 miles an hour, or wherever if it's venting that direction. And if you put your hands next to it, you can't hardly feel any heat,
Right.
because not much heat radiates away from it. So the firefighters go, oh, well, so we only have to worry about what's directly in the flame. We go, yeah, that's one safety thing. Number two, if it's not on fire, they just let the tank empty, and afterwards, they don't even have to hose down the pavement. There's nothing to hose down.
Right.
Everything's gone. It's gone in the air and either turned into clouds, or, like you say, gone all the way through the atmosphere and out into space.
Yeah.
So, you know, hydrogen is really a lot safer than most people think. And usually when the fire department finishes training with the safety folks from California and the Northwest, they just go, wow, this isn't so bad.
Yeah.
One of the strange things about hydrogen for the fire department is that it doesn't have a color to the flame,
Right.
generally speaking.
Yeah.
So they need thermal imagers to make sure that they can see if there's a flame there.
Yeah.
And one of the things we're trying to do is get the city and county and the state to fund some of these thermal imagers for their firemen.
Yeah.
So the safety piece is pretty well, I think, taken care of.
Yeah, I think we have the technology, we have the knowledge, and you know, we have to make sure it's implemented in the right way to ensure it's safe. And I think 99.9% of the people are doing it that way. But we also need to, in my opinion, listen to people's concerns. Even though you and I are familiar with it, we're comfortable with it. When new people come to hydrogen, they have concerns about it, and they're worried it's going to catch on fire and they can't see the flame, and et cetera, et cetera. And it takes a little time to walk them through that, and we can't be dismissive of that,
Right.
because not everybody, a lot of people don't have the experience and knowledge that we have.
That's why we're here.
Yeah.
We're here to give everybody experience.
There you go. Good plug
Okay,
for the show.
we're going to take a quick break here, and when we come back, we're going to talk a little bit more specifically about hydrogen and how it works in a fuel cell, and then we're going to talk about the project with Young Brothers that Joe's working on out here with Sandia Labs. So we'll be right back.
Here's the deal. I'm Jay Fidel. I'm the host of Hawaii, the State of Clean Energy, which is the Energy Policy Forum's program on Wednesday. That's how we call Wednesday Energy Wednesday. We call it Energy Wednesday every Wednesday. Are you surprised? Okay, and we try to get guys like Jim Alberts here from Hawaiian Electric who can tell us what's really going on in energy. We want to be informed. It's so important. It's the most important initiative in our state. Clean energy is major, okay? And that's why we cover it on this show. That's the deal. What do you think, Sharon?
I think that's great. That's why we're here every Wednesday from 4 to 5, and we hope you all join us so we can hear people like Jim coming on our show and co-host Ray Starling from Hawaii Energy.
Okay, Jim, you've been here today. You've seen this. You heard what she said. What do you think?
I think it's a tremendous opportunity for people to come together and talk about the issues. Oftentimes there isn't a good forum to bring these key issues out into the public, and this is a tremendous way to go about it. And the activity of this show is essential to keep talking about energy, because as you said, it's such an essential part of our lives that we need to pay attention to it, and we need to think about the future.
Okay, Ray, your turn.
Well, this is a special time in the history of Hawaii where we're making some pretty radical changes in the way we use energy and generate energy. And this show is the one place you can count on coming to every Wednesday and hearing something about the latest issues that are on the table, being discussed, that will affect us all going forward. So come join us, and if you have some ideas you want to share with us about energy, give us a call and let us know. We'll put you up here and let you talk for an hour. So come see us.
Thanks, Ray. Thanks, Sharon. Thanks, Jim. It's great to be, from ThinkTech's point of view, it's great to have this show. We love the show. It's our most important show. So come around and listen to us 4 to 5 on Wednesday. Thanks a lot. Bye.
Aloha.
Aloha.
All right, you're back with Stan Energy Man on my lunch hour. And we've got with us Joe Pratt from Sandia National Labs, and he's got some interesting tools in front of him that we'd like to show you. Number one, how hard it is to make hydrogen, and number two, a little bit about what an electrolyzer or a fuel cell looks like, what's inside the Young Brothers container. So, I tell folks that, the way we get gasoline is to go to Alaska, drill a bunch of holes, suck oil out of the ground, put it in a big Valdez tanker, ship it downrange, hopefully don't spill any, drive up to a refinery, pump it into the refinery, mix it with a bunch of, including hydrogen, crack the fuel, turn it into gasoline, put it in your car, and you can go 300 miles. Or you can take water and power and make hydrogen. And I go, which one? Yeah, anywhere in the world. You don't have to have an oil field in your backyard. You can make this in your house. You can make it in your office. You can make it in the desert. If you have a water source and you have solar power, you can make hydrogen right from the solar power and the water source. And it's clean with no carbon. And then you put it in a fuel cell and you get energy back. Some of the energy you invested breaking that water apart, you get that energy back and you get water for a byproduct. So no carbon, totally green. You don't have to drill oil wells. You don't have to spill oil all over the place. And I go, this is so basic. So maybe it's so easy, it's scary. Maybe it's so easy, nobody can believe it. Like, what, I can drive my car on water? Yes, you can drive your car on water. It is that simple, but we haven't been using it. but we've invested 100 years in drilling holes and pulling oil out of the ground. So this is the technology of the future. And I think in Hawaii, the future's like right now. It's here already. And your project out at Young Brothers is gonna be one of the ways we show people that. So why don't you tell us about this electrolyzer you got going in front of you and
Sure.
what it's gonna be doing, and then we'll talk about the fuel cell.
Okay, great. So I just have a little demonstration here, magically appeared during our break. This little blue thing here is the electrolyzer. Electrolyzer takes water and it splits it using electricity into hydrogen and oxygen. So as Stan said, you could hook up the electrolyzer to any kind of power source, wind power, solar power, anything like that. Right now I have a battery pack because we're not outside, but you could put a solar panel here too. So pretend this is the electric grid and we're feeding power into the electrolyzer. It has two sides. One, you make hydrogen from the water, and the other side you make oxygen. So I have these little tubes that will take the gas and send it into these vials, and you'll be able to see the hydrogen and oxygen being created. Now, what I don't show you here is filling it with water, but before this demonstration, I filled the electrolyzer with water, so that's where the water came from. So I'm going to turn it on, and then what you'll see, going into the, if you can see it here, you have two levels of water. You have one here where you can see the water level slowly rising on the outside, and then inside you can see another level that's actually decreasing. So the hydrogen's coming in here, it's going into this little cup, it's pushing the water down, so it's displacing the water, and the water's coming back up. So
Yeah, it may be hard to see on the camera, but inside those two cylinders are inverted clear plastic containers with a little hole in the top that the hose is going into. So the gases are going into the top of the container, and as they fill up with gas, the outside water is being pushed up on the outside, and inside the container is filling up with gas and moving, and the line is moving down. So you can see there's quite a bit of gas built up on the negative side already with the hydrogen.
yeah,
And
right here, so the hydrogen's come all the way down, it's
Right.
still pushing the water up.
so, and that makes sense because water is H2O. So there's 2 atoms of hydrogen for every atom of oxygen in the water. So you've got about twice as much hydrogen as you have oxygen in there, which kind of matches the chemistry.
Hey, it all works out.
Yeah.
Yeah.
So it's not what do they call it, voodoo. It's not magic, it's science.
And you can do this anywhere, like Stan said, anywhere where you have water and electricity. Put the electrolyzer, you make hydrogen. In a few more seconds here, it'll actually start bubbling
out.
to the surface.
Okay.
So let it run another 10 seconds.
So again, what you're really doing is you're taking pure water, splitting it into hydrogen and oxygen atoms. Then in the big scale ones, we save the hydrogen, but you can also save the oxygen. That's
Yep.
medical grade oxygen coming out of there. And in our electrolyzer at Hickam that we use to make the Air Forces, we've actually taken the oxygen and stored it and had it tested for purity, and it comes back medical grade oxygen.
Wow.
Another thing we're thinking of doing, hydrogen's
There you
starting to
go.
bubble out now.
Yep.
Another thing we're doing at Hickam is we're looking at taking the oxygen from the electrolyzer and turning it into liquid oxygen to use in the aircraft.
Wow.
So when I tell the Air Force, this is a neat technology because not only do you make the fuel that you need for your equipment on base, for your generators, for your vehicles, and for your stationary power, backup power, but you're making oxygen for your welders, for your medical people, and even for your airplanes if you want to liquefy it.
Yeah.
So you can do it, like you say, anywhere. So you don't need to be shipping fuel in. If you don't have to ship fuel in to the Air Force or the Army, then you don't have to have a convoy. If you don't have a convoy, then you don't have people hitting IEDs and getting hurt.
That's right.
So in the military, there's a context for this, and that's what I try and do on my side as I show the Air Force these technologies. So we're splitting the water, and we're saving the hydrogen. We're packing it in a tank with a compressor or hydride compression, non-mechanical. And then we have to turn it back into electricity. So this other piece of gear you have here
Yep.
is the fuel cell.
Yep.
It takes the hydrogen that you're making over here, and it turns it back into water
Right.
and electricity, a little bit of heat, and that's it.
Yep.
No carbon monoxide, no carbon dioxide, that's it. Just energy and a little bit of heat. And in some of the more advanced fuel cells, They even capture that heat and they turn that back into more energy as air conditioning, heating, other things, heating up water, things like that.
Right.
Okay,
Yeah, so what I can do is this one's not a working fuel cell, but I can take it apart and show you the pieces.
Sure.
If you'd like, okay. So a fuel cell is kind of like a big sandwich. You have these end plates here, and oxygen will come in one side and hydrogen on the other one. And then I'll show you what's in the middle. Up here at the top, you have these two connectors where you would get your electricity off, so positive and negative, just like a battery. And you know, a lot of the times when I talk to people about how a fuel cell works, I just say it's pretty much the same thing as a battery. You have an electrical reaction in there, a chemical reaction that's producing electricity. The good thing about a fuel cell is as long as you keep giving it hydrogen and air, it's a battery that never runs out.
there you go. Another nice thing about hydrogen compared to a battery is because it's so lightweight, you don't have to have 10 tons of batteries in your car.
Yeah.
You can store 50 pounds of hydrogen.
Right.
And you get the same kind of energy return with a lot less weight in your vehicle. Now, I know as an Air Force guy, that's important in airplanes, because in airplanes, when you design an airplane, everything has to do with weight.
Right.
You need to keep the weight off the airplane. Everything you add into the airplane, you probably have to take something else off.
Yep.
Okay, so now we're inside the fuel cell.
Okay, so I don't know if you could see this on the video. Okay, there we go. So this is a metal mesh that they have here, and it helps to distribute the hydrogen or the oxygen all around the fuel cell. And it's made of metal because when the electrons come off in the reaction, it captures those and it sends it up to your power lead.
Okay.
So we take off that metal piece, and there's another one on the other side over here. And so now we're left with what they call the membrane electrode assembly, or MEA, people refer to it. And this is really simple. You have a piece of, it's carbon, mostly like a felt on here, and the carbon is mixed with tiny little particles of a catalyst. In most fuel cells, you're still using a little bit of platinum for that. Some other fuel cells use different metals at higher temperatures and things, but so the hydrogen or oxygen comes in here, it reacts, and then in this type of fuel cell, the hydrogen splits into two, so hydrogen's H2. You split it into the two H's. The two H's go through the middle here. See this piece of plastic? It looks like a saran wrap, right? Plastic wrap for your food. That lets the hydrogen go through the H's, makes the electrons go around, right? So then you complete your circuit. They join on the other side. The H's come through, they join with the oxygen from the air and the electrons, and they're making water.
Okay.
So that's it. That's all you've done is you got a chemical reaction here, producing electrons, which you send to your light bulb or your car engine or whatever it is, and then you're making water.
So
no
that
moving
carbon,
parts.
yeah, that carbon screen in the middle then, I have heard referred to as a catalyst.
Yeah.
And in chemistry, the catalyst is it takes part in the reaction, but doesn't actually, it's not physically taking part. It accelerates a reaction, but it doesn't actually take part in the reaction. So we're getting basically hydrogen and air in here, and the oxygen and hydrogen make your electricity, and then come off as water.
Yeah, you're not consuming any of this, right?
So this
It's
lasts
always there.
forever,
Yeah.
essentially. As long as you don't contaminate it,
Yeah.
it lasts pretty much forever.
Yeah, so, you know, when we show this to guys who are used to working with car engines or generators or things, it's like, you know, okay, this is it. There's no piston moving up and down. There's no oil that you have to fill it with. There's no moving parts. You just have this thing sitting here and it's making electricity.
Great, Joe. That's awesome. That's better than my cookie jar that I have in my office to show people this. So it works a lot better. We're going to take a quick break and be back in about a minute and a half. And you'll come back to Stan the Energy Man and my lunch hour. And we'll talk to Joe some more about what's going on with Young Brothers.
Okay.
Hi, I'm Ethan Allen. I host Likeable Science on ThinkTech Hawaii. And I do this because I care about science literacy in Hawaii. I want to spread the understanding that science is a vital and interesting part of everyone's life. I want to make sure the broadest possible spectrum of people understand the beauty and the value of science and realize that science plays out each and every day of their lives. I want you to understand that science is fun. So we bring onto this show each week guests who are scientists, from astronomers to zoologists, and we talk about what they do and how they do it. But most importantly, we talk about why you should care about their work, why you should see that their work has value and impact on your life. So I hope you'll join us Fridays, 1 p.m. here on ThinkTech Hawaii. You can watch us via live stream. You can watch us recorded on Olelo, and you can see us each week. We hope you'll join us.
Welcome back to my lunch hour. Stan the Energy Man here, and we're talking to Joe Pratt, Dr. Joe Pratt from Sandia National Labs. And we've been talking about electrolyzers and fuel cells, but Joe's really not here to be on ThinkTech. He's actually being paid to do some work with Young Brothers. And one of the things that I do in the state of Hawaii with our technology is we try and solve some of the environmental and energy problems that we're trying to make better or fix. And one of the things that happens around our harbors and our airports is we have equipment that's run primarily off diesel generators, which are not the cleanest equipment running. So Young Brothers and a lot of other inter-island barge services and boats use diesel fuel because diesel is much safer than gasoline on the maritime world. And so they use this technology, but it's not really very clean. So I think Young Brothers and Sandia and the Department of Energy got together and said, hey, is there something better? Is there some technology out there that's better to use than diesel engines? And the answer was, how about hydrogen fuel cells? So Joe, why don't you tell us how this kind of got started? Because
Yep. Sure. Yeah, so it started actually about 3 years ago when Department of Energy heard about using fuel cells in maritime applications in general. And we did a study where we looked at, okay, where would it fit in the maritime world? During that study, I got in touch with Young Brothers. We were actually looking at putting fuel cells at their docks to power their tugs when they weren't being used, so they didn't have to sit there idling. They could just plug in, like, get electricity. But then they said, hey, you know, we have this other thing over here where we use these big diesel generators to power our refrigerated containers. So all of the groceries and everything, and the pineapples that goes back and forth between Oahu and the other islands is transported in these big shipping containers that have refrigerator units on the end. It's really just a giant refrigerator, but those need power just like your refrigerator at home. So they plug those into diesel generators.
yeah, we have it on the screen right now.
Oh yeah, there's our fuel cell unit getting fueled at Hickam. So what they said is, you know, maybe we could do a fuel cell in place of these diesel generators to keep our refrigerated containers cold as they're going back and forth between the islands. And when we looked at the cost analysis, you know, I mean, Young Brothers is a business, right? So it's really environmental benefit, but they have to be sensitive to the business side. And we looked at potential costs of hydrogen in the future and potential costs of diesel, and we saw a possibility that they could save money in fuel costs by switching over to hydrogen fuel cell technology. So that's how, you know, they kind of raised their hand and volunteered and said, hey, we'd like to try this out if you're looking for somebody to help develop this. So that's kind of how it all started.
Great. So you worked with Hydrogenics, I guess, is the company building the fuel cell.
Yeah.
And they designed, working with you, a 20-foot container with a fuel cell that you just showed us here, but a big one.
Yeah.
And how many kilowatts is that fuel cell? About 100 or?
So it's 120 of fuel cell power, 120 kilowatts.
Okay.
The unit itself has a lot of fans and things in there, so it uses some of that energy.
Okay.
So the amount of power that we can send to the reefers, the refrigerated containers, is about 100 kilowatts.
Okay.
Yeah.
So it's about 100 kilowatts of power available to be used. And you have onboard storage of hydrogen in the container.
Yes.
And so what that picture showed was the container being filled with hydrogen at our station at Hickam,
Yep.
Hickam Air Force Base. So this was kind of a neat project because it brought together the Air Force, Young Brothers, Sandia Labs, Hydrogenics, and the folks that wanted to demonstrate clean technology in Hawaii. And this is perfect because if you're ever in the area around the docks, you see how much your heavy equipment's moving and how much power is needed. If you think that all those forklifts and container movers and even the tractor trailers that haul the containers around could all at some point be running off fuel cells, just think how much cleaner those operations would be. Not only cleaner, but quieter.
Yeah,
Because
quieter.
a fuel cell doesn't make it, you didn't hear it making any noise. I mean, things making noise over here. When we run our fuel cell bus at Hiccup, people are amazed because they're like, okay, when's the engine starting? It's not. You can sit in the front of the bus and the back of the bus and carry on a conversation and not have to raise your voice because it doesn't make any noise.
Yeah.
So there's some cool advantages to it. And you mentioned that it was cost effective. And I know that one of the things the national labs do, all of them, when they look at these things, they do look at the business side of it, and they do try and make sense of it. In Hawaii, we have the most expensive power in the U.S. for the most part, at 30-something cents a kilowatt hour, where other cities maybe as low as 10 cents or 12 cents a kilowatt hour. We're paying a premium. So if this can work here and make money on the scale that we use it, it can pretty much be used in other places. We just have to make sure the price keeps dropping down.
Yeah.
And as I tell folks, oil is a limited commodity, no matter how you look at it. We may have years of it left, but it's still a limited commodity. And if you're into economics at all and supply and demand, the supply is going to get smaller. But hydrogen, and all we're doing is turning the atoms into oxygen, hydrogen, and back into water, and back into hydrogen, and back into water. We're not really burning it. We're just recycling it all the time. We're not going to run out. So as soon as the technology in hydrogen gets cheaper and cheaper, you're going to watch the price of oil still going up and up because it's getting used for plastics and other things.
Right.
So in the long term, a lot of companies are going, it makes sense to look at hydrogen for your energy technology.
Yeah, for sure. I think, Hawaii is a special place because of all the energy and fossil fuel that needs to be imported to keep the state running. At the same time, you've got incredible renewable energy resources with the trade winds blowing all the time and the intense sunlight down here, in the southern, compared to the mainland, right, a little farther south.
Yeah, I tell people we're in the deep south. They don't know.
The deep
Hawaii is the deep south.
So it's really a perfect place to capture renewable energy, to store it as hydrogen or electricity, however you're going to do it, and fuel the island, really, off of what comes down from the sky.
Okay, so as an engineer and familiar with this technology, and understanding that our governor just signed a law about a month or so ago that says Hawaii is going to be totally renewable by 2045. Realistic?
I don't see why not. I mean, I have to hedge this as an engineer saying I haven't done the calculation, but with the amount of, wind you have blowing here all the time and the sunshine and the places you can put solar panels, I was amazed when I flew in how many solar panels are already on rooftops. I think you've probably got more than enough energy to do that. I don't see why not.
And this thing, we haven't even talked about the potential for power from the volcano.
Yeah.
For,
Geothermal.
Geothermal power.
Right, yeah.
And one of the other projects that we work on over here on the Big Island at the Natural Energy Labs is the ocean thermal.
Yeah.
Because you have such a huge temperature differential when you pull water from the deep ocean and bring it up to sea level. You can use that temperature differential to run different energy producing equipment,
Yep.
like Stirling engines and things like that.
Yeah, for sure. Yeah, so much energy resource here. I think it's really a perfect place.
So hear that, Governor Ige? We can do it. He hasn't done the calculations yet, but we can do it. I'm confident we can do it. And all it takes is just applying some of this technology.
Yeah, that's right.
And I think it's really cool. I really love this. I think I've got to buy myself one. I don't know if I can afford the fuel cell, but I'm definitely going to buy one of those electrolyzers.
Yeah, I'll let you borrow it.
Okay, thanks. But, so Young Brothers project is gonna go on until the end of the year, or how long are they gonna test that?
Yeah, so actually the reason I'm here these 10 days is the fuel cell unit arrived last week, and Hydrogenics came here with their technicians to commission it. So make sure everything's okay after shipping it, getting it up and running, using it in the actual environment. Just like with any piece of equipment I've ever experienced, the first time you turn it on, there's always a bit of learning and fine tuning you need to do. So that's what we're doing this week. But this kicks off what we call the deployment phase of the project. So we had design, we had building, and now we're in deployment. 6 months is the intended length. We have, we can go longer, but that's sort of what we're starting at, about 6 months. So for the first little bit here, it's kind of an undefined time, maybe a month or two. It will be sitting at the dock at Young Brothers, powering their reefers while they're still there. So there's a time delay between, when they fill the reefer full of food and then when it actually gets on the barge, or vice versa when it comes off. So they need power while they're sitting there on the dock to keep it cold. So they're gonna, everybody's gonna feel comfortable. Technically wise, we want to make sure the unit's running right. Young Brothers wants to make sure it fits in their operations right. When everybody feels comfortable, then they'll start putting it on the barge to Kahului on Maui. So it'll be powering the reefers over the water on that. I think it's about a 12-hour trip over to Maui. And it's an unmanned barge, and there's no way to fix it if it goes wrong. So that's really why we're taking it step by step.
Great.
We're shooting for 6 months total on that one.
So as we designed this piece of equipment, and I know because I was in on a lot of the teleconferences that we talked about these things, what are some of the different aspects about doing a fuel cell on the ocean that are different than doing the fuel cell like we have at Hickam, that's a stationary fuel cell on land?
Yeah.
What are some of the different considerations you had to look at?
It's interesting, Stan, because there's not that many differences. I mean, Young Brothers had to, Hydrogenics had to ruggedize everything inside, but that really was about the handling of it, and a lot of handling, moving it around and using forklifts and things to move it around. So kind of ruggedizing it so it wouldn't get damaged during that. As far as, being at the port, technically, one of the things we had to do was install these salt filters and everything.
Okay.
So we make sure the air going into the fuel cell and even into the room with all the electrical equipment is clean because of the corrosion issues. But other than that, I think there were the bigger issues with putting it in the maritime environment and onto the barge were regulatory.
Right.
So we also worked with the U.S. Coast Guard. They've been a part of the project since the beginning, and the American Bureau of Shipping, to have them review the design to make sure not only does it comply with the rules and regulations in maritime, but also just standards for safety and reliability.
Outstanding. Well, believe it or not, we've zoomed through 45 minutes, and it's about time to wrap it up. So Dr. Pratt, thank you so much for bringing all your stuff down to show us.
Sure.
And sharing a little bit about what you do and what we're doing with Young Brothers over across the street, down the road.
Sounds great.
And we're looking forward to maybe having you back later on and telling us how the project went. And maybe we'll even talk to some Young Brothers folks and see how they like using it.
Yeah, that'd be great.
Thanks very much.
Sure.
Great having you here.
Yeah, pleasure to be here. Thanks, Dan.
All right, thanks everyone for joining me on my lunch hour. This is Stan, the Energy Man, and we'll call it a wrap for this week. Aloha.